Okay, I think we'll start and restart the lecture again. Sorry about the connection issues earlier. Hopefully we don't have any problems now. I guess if you aren't able to see this live, you'll be able to catch it afterwards on YouTube anyway. Okay, so we'll go straight to this, and this particular, it's week 8, it's CS264. This is lecture 15, and we're going to have an introduction today to software design patterns. So we're going to learn about patterns, why we need them, why they exist, what their purpose is, and the different kinds of patterns as well. And also we'll go into a little bit more detail about two behavioral design patterns called command and memento. And these would be of interest to you because you've been asked to work with these in your assignments. So first of all, though, I would like to recommend a textbook. I normally we give books that are online, and this one isn't available unless you buy it. So I'm always a bit hesitant about recommending these kinds of texts, but I do think it's worth it. I don't think it's particularly expensive. I'll use lots of examples, and using this book called Dive into Design Patterns by Alexander Svets. It's very accessible, it's very readable, has lots of nice examples using C#. In its accompanying website, which is called refactoring.guru. You can click through to the microsite refactoring.guru/design patterns in order to be able to get all that information around how you implement design patterns and how you implement them in C#. And I'll tell you what they are and so forth. The price of this is €10. I think it's worth it. In addition to this book, it gives premium website access. It also gives access to all of the code examples. You don't have to buy the book. Of course, you can just look at the website as well. There's lots of material will be there. You don't have to buy any book. It's just a recommendation, but it has some really nice stuff in there and definitely worth checking out. I mean, this is not me a paid advertisement or paid support for this. I get nothing for this. I just recommend the book. Let me show you the book quickly. So it's very nice. You can see there's some C# code. It has all sorts of information about Solid, for example, which we talked and touched on last week. It talks about principles of OO design. It does a lot of this stuff. It's very nice, very accessible, very, very readable. But what's beautiful about it is that it goes through all of the various design patterns, tells you about why you need them, what the basic idea is, how it works. Here's Singleton. We talked about this before. It explains sometimes with cartoons how you build a real world analogy for this. Shows you the code, the UML. Again, gives you some pseudocode and then gives you code. It's really, really nice. It's definitely worthwhile checking out this book. Okay, so I'd certainly recommend this. Okay. So what are they then? What are these design patterns? So they represent the best practice used by experienced object-oriented developers. Okay. They're solutions to general problems that software developers have faced during software development, and they've been obtained by trial and error by numerous developers over quite a substantial period of time. So if you think of the original text, like back in the 90s, and the object-oriented software has been around since the late 80s. So it's people have been doing this a long time and have lots of experience that they can share. So I like the second description here, which is this one. It tells us that design patterns are reusable assets that encapsulate the OD principles, such as low coupling, high cohesion, and embody design knowledge with regards to identifying class-object collaboration, responsibility, distribution among objects, etc. So it's nice, and I took this one from an article by Zhizhao from Dunstan Thomas Consulting. They have a really, really nice summary article on design patterns, modeling in UML, and implementation using C#. I think it's an excellent summary article. It gives you a full description, full background really on what patterns are, why you need them, and so forth, and talks about an abstract factory pattern. It gives you beautiful UML. It gives you both kinds of class diagrams and interaction sequence diagrams, and then some code, and there's a real sense of trying to convey exactly what's happening with this in detail, but still very readable and accessible. I'd recommend it. You can click through on the link at the bottom here in order to be able to get access to that. The author actually tells us that designers are overwhelmed by the options available. So experienced designers make good designs by applying reasonable and flexible design solutions called design patterns. And this being overwhelmed is nothing new. I mean, I know you have your third year students now. You have assignments that are harder than they would have been last time. They're bigger assignments. They require you to invest a lot more time. And the issue is that, the theory and the idea behind all this, of course, is that, not that you become swamped and, you can't do anything, but you get a sense of what real world software development is like. And you see the necessity for patterns that, there are real complex tasks we're asking you to do. And it's not like they're tasks that other people haven't encountered before. And the idea is to try to build on what these people have learned and tell you about how you might go about building a solution. And just as it is with your current assignment, for example, where you have to build an undo redo functionality for a simple command line interface UI, people have been doing this kind of thing in the past. And also, there are contested views about this. There are patterns. There's a pattern called Memento. There's a pattern called Command. So which do you use, and why do you use this one, and why do some people favor one over another? So that's really, really important that you understand that these are not solutions per se in terms of coding solutions, and they're not absolutes. They're recommendations and ideas that you need to understand, look at your context, and then use them. So that's why we want you to know about design patterns in this module. In object-oriented design, this pattern is a general, repeatable solution to a commonly occurring problem in software design, therefore. Okay? It is not a finished design that can be, and it can't be transferred directly into code. Okay? Into your code. I mean, it doesn't come as a bunch of code that you could just drag and drop into your code and say, well, I can use this. Okay? It's a description, it's a template for how to solve a problem that can be used in many different situations. It gives a best practice based on existing knowledge and experience. And those words, existing knowledge and experience, okay? That's really, really important because, as languages change and facilities and functionality appear in languages, we may think about how we do OO differently than previously. And so maybe the patterns might change, we might get new patterns and so forth, okay? So they're like pre-made blueprints that you can customize to solve a recurring design problem in your code. Patterns are not algorithms. They're a high-level description of a solution. It's not like saying I need to sort something, so I need to implement how to implement a quick sort in my code. Okay, it's not like that where you can just take the code, works, and there you have it. I want to build a stack functionality in my code. You copy and paste, work, and it'll just be fine. It doesn't work like that. You can't just find a useful pattern and then copy it into your program the way you can with off-the-shelf functions like libraries and then hope that it'll work. Okay, it's not a specific piece of code. Although you will see specific pieces of code as part of the demo code that accompanies the patterns, but they're really dealing with some generalized concept and showing you how you get from the pattern to code. That's the purpose of the code in these. Okay, so that when you look at your problem, you understand that the pattern that will work for you, and then you can then make it work in code, but still adopt the recommendations of the pattern. So it's this general concept for solving a particular problem. So you can follow the pattern details, then implement a solution that suits the realities of your program, okay, about your reality. So there are what are these essential elements then of a design pattern? So when you see one, how do you know and recognize it? How does it work? So there are 4 essential elements for every software design pattern. There's the pattern name, that's something succinct, and it's used to describe some design problem together with its solution and the consequences. And it also provides the intention detail. Okay, so what's memento mean? And it's a concise way of saying saving a memento. What's a command pattern? It's something to do with commands, obviously. So it also then the next element is the problem or motivation. That describes when to apply the design pattern. So when we know that we want to apply a pattern for doing undo and redo, for example. So what's this? The next element is the solution or the structure, and that describes the different elements that make up the design, the relationships, responsibilities, collaborators, all that stuff. Okay, and that's often given in terms of the UML. So you'll have static diagrams and structural diagrams, and also interaction sequence diagrams, for example. Then there's the consequences, and they're the results and the trade-offs associated with applying the software design pattern. So some of these will, if you do use a pattern, there are consequences, and you might need to know the pros and cons of the various patterns. And we'll see that a little bit later as well. Some pattern Catalogs list other useful details, such as the applicability of the pattern, the implementation steps, and the relationship with other patterns. And they might also include code examples, and that help grasp the purpose or the intention. And that little book that I recommended earlier, Dive into Design Patterns, also gives some nice diagrams, cartoons, all of that stuff to help with trying to memorize and understand and get them. I don't expect you to know all of these patterns. I mean, most software developers may never encounter a pattern at all, never feel it necessary to use one. Or may just work with one pattern because that's applicable. In fact, they may not work with design patterns at all. They may work with architectural patterns, which we'll see a little bit later. Okay, but it's a and I certainly don't expect you to know all of them. But what you don't understand, some of them you should be able to work and work with some of the rest of them. Okay, so you hear often about the Gang of Four, the GOF design patterns. I've mentioned it before, and so where does this come from? And then there are 23 patterns there. Okay, the concept of patterns then was first described by Christopher Alexander in A Pattern Language, Towns, Buildings and Construction. So it wasn't anything to do with software at all, and it describes a language for designing the urban environment. And the units of this language are patterns. Okay, so they describe how high windows should be, how many levels a building should have, a large green area should be, all that kind of stuff, and it's done with patterns. And the idea then was picked up by 4 authors, Gamma, Zisides, Johnson and Helm, and in 1994 they published this book, Design Patterns, Elements of Reusable Object-Oriented Software, and I've told you about this before, and they applied the concept of design patterns to programming. And there are 23 patterns looking at solving various problems, design, and it became a bestseller. People then just refer to it as the book by the Gang of Four, and then it's just a GOF book. Okay, so that's where it comes from. But according to these authors, design patterns are primarily based on the following principles of object-oriented design: program and interface, not an implementation. That's really interesting. Okay. And then favor object composition over inheritance. So it would be worthwhile checking out that book at some point and see, where those two languages and two ideas come from. It would definitely be worthwhile. Okay. You'll notice as well that there were this 23 patterns. The book, Dive into Design Patterns, actually only gives 22 of those patterns. Okay, it doesn't have the interpreter pattern. It's missing. And sometimes you'll see that there are 26 patterns around. Okay, but that's because new patterns appear. It's 1994. It's unsurprising that, it would be surprising if there weren't new patterns following on from then. Okay, so what we tend to do then is we look at classifying patterns. Okay, so the most universal and high-level patterns are architectural patterns. And developers can implement patterns in virtually any language. Okay, but unlike other patterns, they can be used to design the architecture of an entire application. The most basic low-level ones, then patterns they're called idioms, and they apply to maybe a single programming language. So design patterns are in between here, and they vary in their granularity and the level of abstraction that they have. But because there are many design patterns, we have to organize them into various groups. So the classification helps to learn the patterns in the catalog faster, can direct efforts to find other appropriate patterns also. So, if you're looking at trying to figure out, okay, so there are 3 different categories. There's creational patterns, structural patterns, and behavioral patterns. And then that's based on the software design pattern's intent or purpose. So behavioral ones are about interaction. You can think about that. Structure tells us about how, classes are structured, and creational, maybe they're a little bit more finer granularity. So it's worthwhile looking at those as well. And we can see those. Again, you can go and look at the Dive into Design Patterns book and see these lists. You can go to Wikipedia, for example. It has a brilliant selection of these as well. Maybe I'll just go there and show you. Let's have a look at the website. Okay, so if we look at the design patterns, you can see there are patterns here, and let's have a look at the catalog. This is the catalog here. Okay. Catalogs over here: creational patterns, structural patterns, behavioral patterns. So again, here are some various patterns. And if we go down to let's go look at the behavioral patterns. Then we'll see, look, here's command, and we'll see command a little bit later, and here's Memento. that's part of that pattern as well. So we look at this, and you could go to Wikipedia, and it will give you a list of all the patterns as well. So again, they're broken into the various, we have the creational, structural, and again we have the behavioral. And you can maybe, let's have a look at interpreter. Okay, so this interpreter pattern is one of the original patterns from the Gang of Four, and it tells you about how to evaluate sentences in a language. So it's how you represent these. But what's nice about this again is it gives you this overview, and it shows you, a UML class and an abstract tree. So these give you the notation and the information that you'd like to be able to use. Gives you an example, and again some code on how you might work with this. So it's worthwhile searching around and finding these. You'll find lots of them. There are many sites that will help you with this. So let's think about creational design patterns. Okay, so for example, they provide object creation mechanisms that increase the flexibility and reuse of existing code. The creational design patterns also provide a way to create objects while hiding the creation logic. So rather than instantiating objects directly using some new operator, so this gives applications more flexibility in deciding which objects need to be created for any given use case. Okay. So we've seen the singleton before. I mentioned it, and I mentioned it. We didn't do it formally, but I'll give you a sense of what the singleton does. And it's used to create a basic class that will only have one instance. So, for example, it's a way to provide a global variable defined in the source code of a program. It's nice. There's one called the object pool pattern, and that's used to create a class with a pool of objects that can be retrieved as needed instead of being recreated. There might be some work around that, or you might be providing an API or some information to people that, is controlled. You don't want to be able to create infinite numbers of these things. Like, it can be used for caching purposes, and you might see connection pools in network applications where you want to reuse connections. You don't want to have infinitely numbers of connections. So, there's lots of ways in terms of the way these things work. The structural patterns, they explain how to assemble objects and classes into larger structures and keeping the structures flexible and efficient. And these patterns are concerned with classes and object composition. And OOD inheritance is used to compose interfaces and define ways to compose objects that continue functionality. So it's nice. So structural design patterns define the relationship between objects. For example, there's one called decorator design pattern that allows behaviors and states to be added to an object at runtime. So that provides programmers with the flexibility to add as many classes to an object as needed. So essentially creates a decorator class that wraps the original class, provides additional functionality, keeping the original class methods and signature intact. So for example, if you had a character in a video game that accumulated items, weapons, armor, all that kind of stuff as the game progresses, then the decorator class would be a really, really good framework for doing that kind of work. Okay. So we have the behavioral design patterns next, and these manage effective communication and the assignment of responsibilities between objects. These patterns are specifically concerned with communication between objects. They characterize the way in which objects and classes interact and distribute responsibility. So for example, two classics are command and memento. These two patterns can be used together or individually to perform undo and redo operations in a program. I produced a detailed example of how to use the command pattern in an earlier lesson, 8.4. I used command because I think it's a bit more difficult to implement than memento. Okay, so I did a harder one for you, really, in some respects. The command design pattern describes objects that execute commands that we can use to save them, and the memento pattern records the state of an object so it can be restored to its saved state. Let me fix that little error there. Okay. So what about Model View Controller then? UMVC. You've seen Model View Controller as a pattern. Okay, and you've seen the variants MVVM, Model View View Model, all that stuff. And you would have heard me referring to these as a pattern also. So what kind of pattern are they then? Okay. Are they design patterns also? If so, then are they behavioral, creational, or structural patterns? So if I remember correctly, and a while ago, I indicated that these were architectural patterns, not design patterns. So what's the difference then between a software design pattern and an architectural pattern? And is it just another way of saying the same thing? Well, actually, they differ. Our design patterns differ from architectural patterns in their scope. They're much more localized. There's less impact on the code base and the impact on a specific section of the code base. The architectural patterns solve the problems related to the architectural style of the application. So are we building a standalone application that we distribute? Are we building a web-based accessible program? Are we building a plugin? These are the bigger architectural styles, and then we have patterns that help with the realization of those styles. So architectural patterns then have this extensive impact on the overall code base, and really the impact on the application horizontally, in other words, how you structure code inside layers, or vertically, how the request is processed from the outer layers to the inner layers and back again. So think then about MVC, that really is like an MVVM. They're each an architectural pattern that you use with an architectural style. So then Model View Controller is an example of an architectural pattern. Okay, and they are also patterns. They provide a recurring solution to a recurring problem as well, but it's a bigger issue. So distinguishing between the design and the architectural patterns is all about the scope. And this was really nicely described in an article, it's a blog post actually, by Alberto Grassi. And I've linked that below. I think it's worthwhile reading and seeing the difference between those. I also found a really interesting article by Ezra Azrardi on design or architectural pattern. Okay, and it discusses the differences between both kinds of pattern, and that's worth knowing. It's the kind of question you could be asked in an interview for your placements and so forth. So it's worth reading. It also refers to situations when you can find conflicting information online from trusted sources. So, you might go to a source that you trust. So, some website, I won't mention them, they're in the article, and you can have a look yourself. And you'll see that it talks about the fact that, everybody believes stuff they read from their trusted sites. And it might not always be the case. There may be differences of opinion and so forth. So, and so you have to be careful about when you're searching and looking for information material. So I suppose to summarize, in relation to software development then, architecture explains the components and their interaction, and the design explains how each component is built or would be built. So there are architecture patterns and there are design patterns, and both of them are different. Okay. Right, so let's move on then to the different kinds of patterns. We know that we have this catalog, and we have the creational, the structural, and the behavioral sections of the catalog. So the creational patterns then, they provide object creation mechanisms that increase lexibility and reuse of existing code. So we have abstract factory, builder, factory method, object pool, prototype, singleton. These are all examples of creation. We have structure patterns, and they recommend how to assemble objects and classes into larger structures while keeping the structures flexible and efficient. Adapter, bridge, composite, decorator, facade, flyweight, private class data, and proxy. We have the behavioral ones. They describe how to manage effective communication and the assignment of responsibilities between objects, chain of responsibility, command, interpreter, iterator, mediator, memento, null object, observer, state, strategy, template, method, and visitor. So those are some patterns. Okay. The GOF list has 23 patterns, and the recommended text that I gave to you only has descriptions for 22 of the list, and it's the interpreter's missing. And there are other non-GOF patterns, that you'll come across, like private class data, which is here as a structural pattern. Okay, and that's not in the original GOF list, but it's a structure pattern. So you will find more patterns as you work through your research in this and your implementation, and you may go in a company that have patterns themselves and they work with those patterns too. So, but there'll be one of these kind, creational, structural, or behavioral, and sometimes you'll go and find that you have a list of design patterns and you'll see MVC in there. Okay, so some people will still consider MVC to be a design pattern, not an architecture pattern, so it can be a bit confusing over time. Okay, but it's worthwhile remembering and knowing the difference there if you can. Okay, so let's have a look then at command and memento. Okay, patterns. So you're working currently on an assignment that requires an undo redo functionality for a console-based command line interpreter user interface. So I recommended that you consider using one of the gang of four classic design patterns, command or memento, to inform your design. So the memento pattern then, that uses to store snapshots of some complete object state. So in your case, the canvas that contains the shapes. I think it's a bit easier in some respects for your particular application to build and implement a memento pattern. The command pattern shows that what it does is, instead of storing the full state, it stores the difference between the states. So the difference is stored as actions. So in your case, the UI commands, and that can be applied and then unapplied. So when introducing a new action, you apply and unapply need to be implemented for that particular action. So if you think in terms of if you have changes that you're making to a program, let's say, so you're looking at working on a piece of code and you want to save the changes like you do in Git or somewhere, or any of these apps that will do this, then what do? Do you just keep saving the new versions of the code, or do you save the changes that you made to the code? Okay. The deltas, if you like. And then you can roll back and roll forward, you can branch, all that work. That's possible because a lot of the time because of the command approach, rather than just saving the memento, just saving the state of your program code. And you could think then in terms of you say, well, yes, let's just save the code. Let's just save each version of the code, rather than saving the changes to that code and rebuilding it every time we need it. But what happens if you're looking and dealing with programs that have millions of lines of code? Then you won't be saving every time you save something, to Git. You'll be saving millions of lines of code, or you just save the change that you made to that code. Okay. So sometimes it makes more sense to actually implement the command pattern than the memento pattern. Okay. Again, if you're saving, trying to work on a word processor, it's fine, but it's a small document, you could probably just save the states. Not too bad. But let's say you have a CAD design that has for a building or a complex, then it had millions of components. Then do you save every component? Do you just save the state? Or you have huge amounts of space taken up, disk space taken up, or memory space by every single one. So memento may or may not work. So you can see that a lot of this depends on the context. Now your application that you're working on is it's not too complex, it's small enough. So either will work. And in fact, and you've heard it first here, the next assignment will be probably to implement the program again, but using the other design pattern. So your current assignment is due on Friday, and if you had to work on the memento pattern, if you decided to work on the memento pattern and implement it for this one, then the next assignment will be to implement it again using the command, so that you can then look and see the differences and then point out the differences between your two designs. So that will be the next assignment. Okay, so you feel free to tell others if you want. Okay, so let's have a look at these. Okay, so the command is nice. There's nice some glyphs that explain here, and the command essentially gives you can see a list of commands. So it's nice to remember those. And really, what happens is that the command turns a request into a standalone object that contains all the information about the request. And that transformation lets you parameterize methods with different requests, the layer queue request execution, and support undoable operations. Okay, that's nice. Memento, then on the other hand, lets you save and restore the previous state of an object without revealing the details of its implementation. So you don't care how you got to that point, you just want to get back to that point. Okay. So it's a useful way to do this. Okay. So with the memento pattern, really, here you have all of these states. So it's like history, and you maintain all the states, and then you have a current state, and you can undo and redo, move you to that new state. So you can manage an unlimited history And it's in a straightforward way. Sometimes it's more intuitive than the other approach. So every time a history entry needs to be generated, we just crop our history list to the current position, take a snapshot of the current state, and append it to the history list. And that works independently of any actions that are used. Sometimes, I don't know if you've ever used some software where you did something and then it didn't provide an undo operation. I remember you used to be able to work with spreadsheets, and you'd make changes across the spreadsheet or something, and then you'd say undo. You said, oh no, I didn't mean to do that. And you say undo, and it says, sorry, you can't undo that last operation. Okay, so that was because, it wasn't using command, for all of those, because it didn't have an undo description held. There isn't state information that you needed to be able to do the undo. So yeah, it's complex. Alternatively, you could have the current state, and for undo, then you take an object that you unapply to the current state. That undoes, and to redo, you reapply an object to the state. And that object that we have, that object that we're looking at here, that contains the information about the command, it's a command object. So what you do is all the information to perform is encapsulated in this object. So you have two stacks usually are maintained. So whenever an action is performed, the action and its reverse are first encapsulated into an object. So we know how to do this. Then the object is applied to the model state, and then that changes the model, and then afterwards is pushed onto the undo stack. And at that point, then the redo stack is also clear because the information is now outdated. That's how that works for us. Okay? So with undo and redo implemented as command or memento, let's look at the Memento Probes. So the implementation is independent of the applied action. Okay? So once implemented, we can add actions without worrying about breaking history. Okay? It's fast to advance to a predefined position in history. That's interesting when the actions applied between the current and desired history position are computationally expensive. Okay, nice to have saved that. You might be making lots of changes to individual objects or styles in a vector diagram, for example. You might want to change that. Okay, so the disadvantages, the memory requirements can be significantly higher than compared to other approaches. So it depends on the context. In your example, loading time can be slow if the snapshots are large. Okay, so let's look at command. So command probes, the memory footprint for command is very small. We only need to store the changes to the model. And if these are small, then the history stack is also very small. So the cons, there seems to be a few of these. I still like it, okay? And we cannot go to an arbitrary position directly, but we need to unapply the history stack until we get there. Okay? With Memento, you could essentially roll back to a particular state rather than going through the states. Okay? So every action and its reverse action needs to be encapsulated in an object. So if your action is non-trivial, this can be really difficult. So mistakes sometimes in the reverse action are really, really hard to debug too, and they can result in fatal crashes. Simple looking actions usually involve a good amount of complexity. So in the case of a graphics editor, the object for adding to the canvas needs to store what was added, the color that was selected, what was overwritten, all that stuff. So you have to maintain a little bit of state as well as you work there. So it can be really challenging to implement and it can be memory intensive when actions do not have a simple reverse. But you need to know that sometimes it might be best to use Memento and sometimes it might be best to use command. And really what I'm trying to get you to do with your current exercise is I want you to be able to really reflect on what works and doesn't work and why you might want to have it working in a particular way. And which is the best choice, not just because you think it's the best choice, but because you've actually done it, and you've tried it, and you can say something, well, I've actually done it this way, I've done it this way, and this works better, and it's really nice for you. And if you do both, and you understand this, and you came across this in an interview situation, then you have something really, really concrete to talk about. So we can describe the structure of all patterns, and I'm choosing command and memento as examples here. We'll see more in the next few lectures. Okay, I think there are 3 left, and we'll probably just spend some time on creational patterns, structural patterns, and behavioral patterns in the last 3. Okay, so there will be different patterns. So we may revisit command and memento, of course, as well. But we can describe the structure of all of these participating classes and objects using the UML. I have some correction that's happening here, and it keeps changing this on me to patterns rather than patterns. Sorry about this. So yeah, it's nice. So here we have the UML that we would use for the Memento. And you can see that we have some caretaker object. We'll look about that. Caretaker has an originator, which is a state. There's various notes here around this. And we work with the Memento of the state. We can get the state or set the state. We have some, what's nice now as well is that in addition to the static pattern here on the left, static design for the pattern on the left, we also have a sequence diagram, which shows what happens in terms of what's involved in saving the state and restoring the state, and what objects are participating, what methods are called, and how it works. Okay, so it's nice to be able to have this sequence diagram as well. It's really, really useful to have the sequence diagram. I think it will be fine. Now let me actually, I'm going to go back for a second. No, I'll do it after I do this one here. Okay, so the same with the command. So with command, it's a little bit more complex here, and we have an invoker again, which has a command and a receiver that receives the command. So we execute an action. So you can see almost that there's complexity. There seems to be more complexity in the class structure, the static diagram for the command pattern here than this one here, but there seems to be more complexity in the sequence diagram associated with Memento. So how it works is slightly different to how it's structured. So the overall behavior is described by both of these, both the class diagram and the sequence diagram. So we typically use both class diagrams and sequence diagrams. The latter give this timeline of how the object instances communicate for different actions. So we have this static and dynamic models, or static and interaction models. The standard class and sequence diagrams, command Memento, actually these ones were taken from Wikipedia, but you'll find them everywhere. The book, A Dive into Design Patterns, just provides the class. It doesn't provide information on the interaction sequence, but you could have a look at those as well. And I want to go back to an article that I mentioned earlier. This really good article here on design patterns and modeling in UML. I mentioned this one by Ji Zhao. Talks about the various patterns, but I want to show they work with an abstract factory. Okay. And now you'll see some of UML, and you'll see this is very similar to the plant UML that we would have generated here in terms of an abstract factory. And here we have, again, an interaction design pattern. And here's some more, here's an actual application. So you start off with a pattern that's generalized here, an abstract factory, and a generalized sequence diagram here. Okay. And then you actually have a realization of building something concrete from this pattern, and then a concrete kind of sequence diagram. Okay. And then we have some C#. It's really good. It's really, really good. I'd definitely recommend it. Anyway, let's go back to this. Okay, so anyway, what's important is that in terms of the description, we have these diagrams, and they're really useful for us. Okay, so now here's a little bit more detail on the patterns. Okay, so on the left we have the command pattern, and on the right we have actually got some pseudocode that tells you how we get from this pattern to this implementation. And it tells us that some invoker creates these commands that are sent to a receiver. Okay? And that's pretty much what this tells us. But you know, we create a command, concrete command, and they must have this execution here, and then we have command that we produce concrete commands from this that allows us to be able to send and receive, send commands to receivers. That's pretty much. So, for example, if we look on the right here, we have a command here, which is a command. And then we have this command history, which is nice. That allows us to be able to undo and redo. We have command, which is a realization of command. This is like interface, if you like. We've copy, cut, paste, and undo. And they have different receivers. Okay? An undo command, for example, is sent to the application, where the copy, cut, and paste command is sent to the editor. And then we have buttons, essentially, which are equivalent to the invoker, and or shortcuts. And in your case, for your examples, they're not buttons; they're just commands that are typed from the keyboards, and they will allow you to be able to make this happen. This example is taken from the this book here, and the full description is here. So we can work through the descriptions here, the background here. And now we have this description for structure, and you can move around here and see what happens. Okay, so the sender class, the invoker, is responsible for initiating the requests. Must have a field for storing a reference to a command object. This is the invoker here. This is the invoker. The sender triggers the command instead of sending the request directly to the receiver. Sender isn't responsible for creating the command object. Usually it gets pre-created by the client, by some constructor. We have command, which is some interface that executes. This is an interface here. And then we have lots of different commands, and realize. But you can work through the examples of each of these. And that's why I would recommend going to the site, and you can work through this at your pace. Okay, for each of them. It's really nice. And then the pseudocode is here. And there's a full description of the pseudocode too. And then there's the code that corresponds to the pseudocode. Okay. But again, this code works just for this example. It doesn't really work in some. It won't work for your assignments, for example. But a version of it may work for you in your assignments. We can have something similar for Memento. So we can click through to the Memento. Let's just do this. Made a mistake there. Memento should be here somewhere. And patterns. Maybe the link, behavior patterns. Memento. Okay, and this is the Memento. I'm going to copy this. I'm going to add it back to my diagram just to be sure that it's working here. Add it here. I'm going to have it here for a little bit later. Okay. Hopefully this will work for us. You want to, yeah, so it takes us there. So that's fine. Okay. Again, Memento explains how this works, and again, how it will work in use here, and how Memento works to manage history as well. And that history is a way of doing undo and redo. Okay. And there's the structure, and again, we have an example here. The original class, the Memento, the caretaker class, and an implementation. So it's fairly straightforward. And again, we can see that they use stacks for pushing and popping information onto a stack that stores the states. It's fairly straightforward, really. Okay, so we can have a look at that, and then that's one that's based on nested classes. What's interesting is that the reason I like this particular one is, and you don't see this too many other places. The reason I like this book. And here's an implementation of the idea or the notion of Memento based on nested classes. So this is the design that's recommended, the pattern. Here's one based on an intermediate interface. So it's an alternative implementation. And here is one that's based on even stricter encapsulation. So even though the pattern is the same, because a high-level description of how it should work, to note the idea, then the actual structural design can differ from source to source, or from user to user, or person to person. So they're still looking at using Memento, but they're doing it much the same way. But because you have lots of options available to you in terms of how you design classes, there are many ways to do this. So do I just use classes? Do I use interfaces? Do I use abstract classes? Do I nesting? Do I subclass, all of these things that you ask yourself. You can still be implementing the pattern, but doing it in different ways. And I think that's really, really important that you realize this. This is not about constraining you in a way. It's about giving you freedom, but it means that, it gives you some operational parameters for being able to work with that. So, I'll come back to these ones again and I'll discuss these again, but it's definitely worthwhile looking at them. I will work through these in a separate lesson for you. Okay, so in terms of the code, we saw that there were code examples there, and they're highly dependent on the application. So I suppose one of the reasons I chose Command and Memento for you in yours is that because, rather than some other pattern, is because they're highly dependent on the application. You're not going to be able to say, oh, there's code example for this online and I can just copy and paste it and submit it. And it's not about you not getting the marks for the submission. It's about you working through the solution and learning something. Okay? That's what's important here. So it's unlikely that you will have found a ready-made solution that you can deploy in your application. I think the best thing to do would be to use the code that I had. That's more likely aligned with the solutions that you would be looking for. Okay, but you have to understand the example used and how the design for the example is motivated by the individual design pattern. And that's the point of this. And it's the point of the exercise. It's the point of knowing this. And that's why you're doing this particular assignment. Okay? You should examine the implementation, understand how the implementation reflects the model design. When you've done this a few times, you'll develop an understanding of how to realize implementations from design patterns in your applications. Then when you get to know and understand the patterns, you'll be able to spot them in other developers' work and say, I know what they're doing there, and it gives you a sense of your understanding of being able to read large blocks of code. Okay, so examine any of the patterns in Wikipedia or the recommended text, and you'll see an example code. Okay, you need to understand the problem and the design pattern in context to understand that piece of code. It's not copyable and usable. It's very rare that you would have something that would work like this. And remember, companies will be using patterns to develop proprietary code. They won't be giving it away. Okay, so that's it. So, but if you think of sense, and if you look at code, you can see the patterns in the code. Okay, so they're really a communication purpose. They're a tool, and that's what makes them so brilliant as well. Okay, once again, I'd recommend looking at the textbook. Dive into design patterns. You can check it online for free. You can buy the book. Okay, and there's code there, there's examples there, and I'll come back to it and use it again for the remainder of this particular module. Okay, thanks for coming along. I'm sorry we had those delays at the end. Well, we learned about software design patterns, and we learned about two behavioral design patterns, Command and Memento. Thank you very much for watching. And again, I see you get this error here. Look, this is crazy. But look, thanks again for attending. Sorry, it was a bit choppy to start. Okay, and I'll talk to you soon. Bye-bye.